Okay, we are getting close to the point where we will start to draw our cross-section sketches. As you can see, it won't be something really fancy, just arcs and some construction lines. But before getting to that, we have to draw these final cycles, which represent the outer diameter of the rings where the sheet metal component will be located and weld on. Okay, this time we will use as usual our cycle by center point. Instead of moving to the draw panel and select the cycle by center point, what we are going to do is to press down the right mouse button and maintain the button press so that this radial menu will appear on the screen. As you can see, we have two annular rings with a total number of 16 tools available right on the tip of the mouse, and we have the line tool, cycle tool, and so on. So we will move and select the cycle by center point, and then we will input 815 as the diameter, and all we have to do to finish is to select the center point, and there it is. Okay, now the master sketch is over, so you just have to move here and select the close sketch tool or click on this green button to do the same. And right away we will change the name of the sketch to master sketch, master underscore sketch, and then hit finish. Okay, so to get the cross-section sketches in place, we have to define the plane where we will create these sketches. There is several ways to do that, but what we are going to do in this tutorial is to use coordinate systems. So make sure that the features tab is active on the ribbon, and in the planes panel select coordinate systems. And now you have this coordinate systems options dialog which appears, and you have the choice to orient by keying relative to another coordinate system and by geometry. But we make sure that we select the by geometry option and hit OK. Okay, so the first step is to define the origin of the coordinate system. So we will select this endpoint. Now we have to define an axis. There is different way to do that. We can select a point, a linear element, or a planar face or a plane. Okay, I will choose to define the z-axis aligned to this line, so we'll select Z, and we will choose this line as the linear element, then hit the green check or right click to accept, and then we'll define the direction upwards. And for the second element to define, we will use the y-axis and we will select a plane. It will be the XZ plane. Right click to accept, and then the direction will be the same as the base coordinate system, like that, and then finish. Okay, cancel. Okay, so we can keep doing this and define the other coordinate system. Okay, one step I miss is to rename this as 1 because it is located okay, it will be 2 because it is located on the second point. Now we keep going, so again we start with the origin, this endpoint, then we will define the z-axis, this line, and the direction upwards. Then we will define the y-axis, and we'll select the plane and it will be this plane. Right click to accept, and then we define the direction, and we change the name to 3. Right click to finish. Again, start over at this endpoint, define the z-axis using this line, select the direction, and then we'll define the y-axis using a plane, and it is the xz plane. Right click to accept and define the direction. We rename it 4. Right click to finish. Okay, so I will go on like this and define the coordinate systems for all the other points. Okay, I will pause the video, and when I will finish, we will move forward. Wahoo! I'm done. Wow, that was painful, difficult, and boring, but at least it is done. Okay, so I went ahead and I create additional coordinate systems up to this one, but as you can see, I made a mistake here, and I will show you how to edit and fix the mistake. Select the coordinate system and you have this edit definition which appear. Click on it, and the z-axis, which is my first selection, is okay, so the y-axis is not in the right position, so it is the second step. And instead of the x-axis to be normal to the sketch plane, I want the y-axis, so I will select this option, and then again planar face, select the plane, right click, choose the orientation, and there it is, finish. Okay, so before beginning, I mentioned that there were several methods to do this, so let's see how the other methods compare to this one. And to do that, I will switch to another assembly I create, and you will see how to create those planes. The first alternate method I would like to demonstrate is with the use of angle tool, but we can use it directly if you select this point as the reference and this other one, an axis is infer, and select an origin. You can only create the angle plane about the y-axis. You cannot get to the result directly. So what you have to do instead is to create first two parallel using this first option. So the first one will be parallel, let's say parallel to this and up to this endpoint. To make sure I select the endpoint instead of the center of the cycle, which is in the sketch but is not visible, I will switch this option to endpoint. I will pick this endpoint and my first parallel plane is created. Then I will select this plane again and select the same endpoint. Now I have two parallel planes, and then I can use my angle tool, select this one as the first reference plane, second reference plane. The axis of my angle plane is then infer, and I will select this point as the origin, and then position the angle plane using this endpoint. As you can see, the plane is created. Let's see if the plane is associative with the sketch. We will edit the profile and make sure the radial lines dimension is visible. We will edit this dimension, so I will double click and change the formula. So I will add 20 to the angle and enter. Now the value of the angle is 40 degrees, and if I close the sketch and come back, you will see that the position of the plane is updated. Okay, So this is the first method. I will undo. Okay, but the drawback is that you have to manage these two additional planes you just created. For the third method, we have to use a dummy part. So I'll select the dummy part and open it, edit in place. I will hide the master sketch, and the only sketch visible is a copy of the master sketch I insert in the dummy part. I will show you how to do that later. So next, what you have to do is to move to this surfacing tab, and in the surfaces panel, select the extrude tool, and then make sure you have select from sketch, and instead of chain, single. And now you select all these lines. So like that. And when you are done, right click to accept the selection, and now you can input a distance for the extrude. We'll say 400, and that's it. Now we have a set of planar surfaces we can use as plane. Okay, so let me go back to the assembly, and what we are going to do is to change the angle as we did before and see how the planes update. So I'll make to show the radial line dimension, and I will change this value to, let's say, 25, and then close the sketch and finish. Let's show the sketches in the assembly. As you can see, the planes are up to date. Okay, so that was two alternate methods, and for this one, the drawback is that you have to manage this dummy part. So feel free to choose what feels better for you, and that's it. We can now create our cross-section sketches. So let me switch to the working assembly, and we will start from this first coordinate system. We are going to create a new sketch, and for that we are going to use our radial menu. So right click and Alt, and we have the radial menu. The tools are different from what we saw in the sketch environment. So the radial menu is specific to the environment in which you are. So I'll select sketch and make sure that I have this coincident plane option active. I will select this plane, and as you can see, we are now back again in the sketch environment. Okay, right now it is a little bit difficult to see the reference point we are going to use for our sketch, but for the time being it doesn't matter. We are going to use the radial menu again and create a cycle by center point, and we are going to position it somewhere here, and then just create the cycle. We will launch again the radial menu to create a line. So we will want this line to go from somewhere like here up to the center of this cycle and back to outside the cycle. Now we want to trim the extra part of this line and this one, as well as this arc. For that, we are going to move to this draw panel and select the trim tool. We'll select this line to cut, this other one, and this one, and then press escape to finish. Press down the middle button to activate the rotate tool. so we are more inside a 3D environment. Okay, and now we can zoom until we can see this line and this reference plane. Okay, now we are going to launch the connect to constraint tool and make sure that we select the silhouette point. If you cannot select the silhouette point, move to the IntelliJ sketch panel and select the options button and make sure you have the silhouette point active. Okay, so we select the silhouette point and then we select the endpoint of this line. Okay, as you can see, the cycle resizes to adjust accordingly. We will do the same for this endpoint, and we will make sure that we snap to this endpoint or the origin of the coordinate system. Okay, so now we have to make these two lines symmetric about the z-axis. So we'll come back to this relate panel and select the symmetric constraint. And the first thing we have to do is to select the symmetry axis. So you can either select this line or using the quick pick select the z-axis. What we are going to do is select the line. Then we have to select the first element. We select this one, and then the next element, this one. Okay, it seems not to be working. What we are going to do is to drag this line away, something like that, and again we will invoke the symmetric constraint. As you can see, Solid Edge, remember that inside this sketch this line was already selected as the symmetric axis, so it is highlighted and we just have to select an element. We select this one and then this one, and now the two lines are symmetric. The last thing to do is to create an angle between dimension. Select the line as the origin and then select this line and place the dimension, impute 4 degrees as the value. Okay, the sketch is fully constrained and we are done for this one. So we are going to exit the sketch and right away rename it to finish. Okay, we are going to do the same for the other planes. So we make sure that we select this plane, and also we can use the quick pick to select and then enter in the sketch environment. But this time I will not create a geometry. What I want to point out is each time we create a new sketch, Solid Edge automatically orient the sketch normal to the plane, but in this case it is not very helpful because we'll have to rotate and go back to an isometric view. Okay, so to prevent this behavior to happen again, I will close the sketch and cancel. You have to move to application button and Solid Edge options, and in the general tab we make sure that we have this option on tick. Now when we will enter in the sketch environment, the view will not be reoriented. Okay, that was the first thing. The second thing is that we have this same geometry to create a lot of times, so we have to find a way for us not to do the same thing all over again, and a way to do that is to use this tear off sketch tool. What the tool do is basically duplicate the sketch. Okay, so we launch the tear off sketch tool, and the first thing to do is to select a coincident plane. So we'll select this plane as the coincident plane, And now we are going to select the geometry to be copied. You'll make sure that chain is active, and then you will click on the cycle. As you can see, all the geometry inside the sketch is selected and copied into the new location. And then we can right click to finish and rename the sketch 3 and right click to finish. And right away we can select another plane, and using the quick pick we can make sure that we select the right plane, then select the geometry we want to copy, right click to finish, then we rename the sketch and make sure, and then finish again using the quick pick. Make sure we select what is to be selected, and there we go. Okay, so I will go on like that and create the remaining sketches, and I will come back in part 5 to show you how to reposition the sketches so that they are properly constrained to the right end points. Okay, hope to see you there, and feel free to leave a comment below. Thanks for watching.